on. So I know it was a big ask to say, get this to me the same day so I can mark it ready for first thing in the morning. I think I managed to mark Emily's one this morning, or somebody sent me one. Anyway, so, and I sent it back. So when I said bring this sheet, this little booklet handy, I mean, we're going to look over it right now so you can make whatever correction. So be active in that. So these are the coordinates for 2 over x. There it is, just like that. If you've got any of those wrong, then your curve won't be a curve, or rather the two arms of the curve won't look correct at a given point. So that's how it looks. And I've given additional notes. The 2 over x will never touch this. It's reaching up towards infinity, and the y-axis acts like an asymptote, just like the x-axis over here, and also these two branches here as well. All right, you don't need to know that A-level word, but it does have a name. Minus 1 over x, these are the coordinates if you use the calculator, and it's going to be a reflection in the y-axis of the original 1 over x, so it's going to look something like that. This is me working some out without a calculator, so that's not a problem. I remember saying this one's got a lot to answer for because it's x minus 1 as part of the denominator, and this is what it does to the shape. Boom, there you go, just does that. So if you've got any of the coordinates wrong, I want to pause here about 4 seconds. You can mark onto your sheet directly in pencil, and then maybe rub out and redo if you need to. That's how it has to be. So again, just to reiterate from yesterday, when I mark your stuff and send it back, please don't go printing it off just for the sake of my comments and my ticks. I'm just giving respect to those who submit the work, and to show that I'm doing my part as well, and to guide you to go forward. But as we go over it together, make corrections if you couldn't get it to me. Many of you could not. I had about 4 of you back. I had about 4 of you sending me the work. So is that okay? So I'm hoping you've actually copied these down if you got any of them wrong, and it will look like that with the, I'm scared to call it an intercept just in case it's not called an intercept, but anyway, it does pass through the point 0 minus 4, and it's not surprising. There's 0 minus 4 right there. Again, so far no challenge. This is no challenge either. Again, I did indicate yesterday that the coordinates at the end can't be plotted because the scale provided with this question is not big enough. Please note A1. A represents grade A in the old money, so this is grade 7 onwards, all right? It's grade 7 not because you can plot the silly thing, but because you can actually solve this bit. Unless you show y equals 4 minus x, and so obviously the graph y equals 4 over x is equivalent to y equals 4 minus x at the point where they intersect. So just create a couple of coordinates to plot the straight line. That's all you need to do. So I chose when x is 10, y is minus 6. I don't know why I did that, but anyway. So I've got the point 10 minus 6, and here's a clever one. When x is 0, 4 minus nothing is 4, so 0,4 is a great little intercept for a line of y equals mx plus c. And then I did it, and here she is. She's a real beaut. It's quite hard to plot some of these. Obviously, you've got to try and keep your hand really steady to try and draw around here, but you know, this is, you're not a machine. And there's another asymptote flying up there and coming down here. So again, I saw some fantastic answers. There's my 0, 4, and there's my 10 minus 6. I know why I did that. If you just plot a small little line, you can't really judge where the where it's going to touch on the actual given reciprocal graph. So if you make it nice and big, I always say big is beautiful. It really is, where graph is concerned especially. And if you touch it carefully on that, then we should see a point of intersection. Well, actually it's a tangent. It's not even intersecting. It's not passing through. It's touching and coming alongside, and that's 4 squares along, and every little square looks like a half. Yeah, that's why x equals 2. I made a mistake originally. I put 0.2 because that 0 got to my brain. So x is 2, and that's your grade 7 right there. Now I want to get rid of that and call something else up. Of course, any questions, email me. Save it. No, don't really want to. I will call this one up now. Now we're doing exponential graphs. It's already embedded in, I think, 2 of the lessons as an attachment. So certainly on today's one, let's look at these things. These are exponential graphs. Unfortunately, the original sheet still had reciprocal functions on it, so I just crossed it off. It wasn't a Word document, so I couldn't actually hack into it. So let's make this a little bit smaller. Now, here's what an exponential graph would look like. First, we'll do some calculations. So if you're at home, you should be now thinking about how we're going to do this. So this is not 3x, it's 3 to the power of x. Let's start from this end. What is 3 to the power of 3? Sorry? 27, yeah, because it's not 3x. I did say that. It's not 3 times 3. It's 3 to the power of 3, 27. What is 3 to the power of 2? Yeah, because it's just basically, it's 3 squared, so it's 9. What's 3 to the power of 1?
3.
And what is 3 to the power of nothing at all?
1.
Well done, it is 1. Any number to the power of 0 is 1, for sure. Now, this one I will illustrate. What is 3 to the power of minus 1, do you think?
A third. Minus 1.
Well done, it's 1 over 3 to the power of 1. Can you see that? Remember, we've done indices, we've done higher indices, we've done some really powerful algebra. So it's a third. Well, how do you plot a third? Well, good luck with that. At least in my table, I'm going to write down points that work really well with this. 0.3 recurring. There you go. So you write that, and you've got to try and plot a third. What is 3 to the power of minus 2? What does that mean? 1 over 3 to the power of 2, which is 1/9, isn't it? Yeah, 1/9. So 1/9 is 0.1111111111111. I'll just do that, I think. Now this next one's going to be a lot of fun. I'll stick it up here, I think. I won't save it as I wreck my sheet. Remind me not to save this, please. So that's going to be 3 to the power of negative 3, which means 1 over, that's meant to be 1 over 3 to the power of 3, which is meant to be, oh come on,
1 over 27.
D'accord. Now I don't know what that is as a decimal, but anyway, you work it out and you shove it right there. And it's going to be a pain to plot. I'll tell you why, because 1 over 27 is going to be 0.0 something. And how do you plot 0.0 something when it goes up in halves, I think? Yeah, you can't plot it. So it's going to be like a pretend little cross almost touching 0. You can't plot it, but the shape is really going to take off. I just fancy doing this. So I'm going to plot 327 right now. Is that allowed? I'm going to try. I've got to make it smaller though. Otherwise, I won't get it to fit on the screen. So 327, 327.5. I reckon it's going to be about there. This is difficult. 2,9, I can do that, sort of. Well, that's 10. 2 squares back is going to be about here somewhere. Just show how hard it is. And 1, 3, great. 3 is 1 square above the 2.5. So it's sort of the curve going up. When x equals 0, y equals 1. I've got to go bigger because I can't even see it. So I'm just trying to suffer with you. So 0, 1 is it? Somebody confirm? I'm trying to memorize the table here. All right, so I've got that. Now, minus 1 and a third. So minus 1 is here, and a third is not even a half. So I'm going to put a little cross right there and pretend I know what I'm doing. There I go. What's the next one? Minus 2 and 0.1 recurring. In other words, it's not even 0.2. So I'm going to pretend I know what I'm doing and put a little cross there and say, there you go, I'm just above 0. And this next one's utterly impossible. So I'm going to pretend it's there. Do you appreciate the shape, why it's called exponential? Have you ever heard the term used in common speech? It's an exponential increase. That means it really takes off real quick. Yeah, it does. And of course, the fun side is trying to draw a freehand curve on a screen with one of these. Well, let's do it anyway. Oops. Oh, no, it's just, oh, no, I'm not going to try. No, it's embarrassing. I'm going to rub it out. Oh, I rubbed out one of my points. Anyway, it's really hard. Okay, let's just humiliate myself a little bit more. I'm going to imagine there's a point there. I'm going to come across like that and go up the road. Oh, I'm getting good. I am amazing. It will look something like, see, these power graphs take off really quickly because 3 to the power of 1 is 3, 3 to the power of 2 is not 6, it's 9, 3 to the power of 3 is not 9, it's 27. Do you see how the numbers take off really quickly? It's an exponential increase. That's the first one. The second one, let's make it big so you can see it. Anyway, I'm not going to sit and do all these. It's a negative 1. All right, now this requires some cleverness. I'm going to start from here because it's easy working positive numbers. I'm looking to work out 2 to the power of minus 2. Any idea what that is? It's a quarter. It's 1 over 2 squared, which is 1 over 4. So I'm not going to plot a quarter. I'm going to try and plot 0.25. Again, points don't come out good on this thing. You stab the graphics tablet unless you try and draw a naught. And this one's going to be 2 to the power of minus 1, which is 1 over 2, which is a half. Anything to the power of 0 is 1. Now, 2 to the power of minus 1. Oh, watch this one. 2 to the power of minus 1. Remember, it's minus anyway, but the x value is negative. What's that?
2.
Thank you. 2 to the power of minus 1 times minus 1 is plus 1, 2. This next one, 2 to the power of minus whatever minus 2 is. Anybody knows what minus 2 is?
Plus 2.
Thank you. So 2 to the power of 2. Thanks. That was Crystal, I think. Was that Crystal?
Yeah,
it was. Good. So 2 to the power of 2 is 4. Do you see it taking off around the other way now? Now, what about 2 to the power of minus? Please watch my bracket. Minus 3. Can you see that? It's meant to be a minus. Come on. What's that?
8.
It is. Because minus is a plus. 2 to the power of 3 is 8. And this next one's going to be 16. So if you imagine it taking off backwards, it's going to go, I'm going to plot the easy one, minus 4, 16. So minus 5, it's a nice big scale. Minus 4, 16, I think it's 2 squares up. I'm going to try and put it there. And the other one's going to be what? Help me, minus 3, 8. Minus 3, 8, minus 3, 8, minus 3, 8, minus, oh no. I didn't even touch it, it's so sensitive. But then you can't even do dots with it. Right, minus 3, 8 has 2 squares. 9, 8, something like that. And then what have I got?
Minus 2.
Alright, minus 2, 4. Minus 2, 4 is around here somewhere then. Minus 1 is going to be half, right? So that's 1. Half is just a single square. Oh, what a lot of fun I'm having. That can't be right. I don't believe it. I made a mistake. No, it's minus 1 is 2. Because it's 2 to the power of minus x. So I got that wrong. So then I'm going to take my rubber, because that's what you should do as well. Scrub it out and hit it. 2 is going to be 1 square below the 2.5. The reason I knew I made a mistake, Hamza, is because I know that anything to the power of 0 is 1. And I've gone below 1, which is really dumb. So there's my 1. Okay, see, it's sort of shooting down the other way. And what's 2 to the power of minus 1? A half. There you go. That's just 1 square. Oh, so it's going to go something like, here I go. Humiliation time. I missed it. Something like that. Once it's coming back up again, it's not a quadratic graph, you know. It's an exponential graph. So let's just go on quickly. There is some horrific stuff. That's a grade A one. Just plot it. It's all it wants. Oh, Hamza. Now you give me your work back too quickly. It does say there's 2 questions here, right? You've done it twice now. Don't just plot the graph and run on. Find the value of y when x equals 1.5. So you're probably going to read off the graph like that. Find the value of x when y equals 11. So you go up to 11, I don't know, up here somewhere, and maybe read off the graph and come. Do you know what I mean? So show that as evidence and don't miss out the questions. That's a fancy one. Is there anything to do with it? Use your graph. Here you go, Hamza, look. There you go. Use your graph to solve that. In other words, where y equals 7. So you go up here and go, y equals 7, boink, boink, read it down, whatever. I don't know. Then it's going to get really nasty. I'm not even going to talk about this This says A star, so you're looking at grade 8. You've got to match the right graph with the right graph drawn. So, and then there's something about rabbits, and then there's something ridiculously difficult, but most kids can make it a start. I don't expect anyone to be able to kill it. You really have to think outside the box for this. So I'm going to stop the sharing right now. Let's just come on top, come to the fore rather, and I'm going to leave you to do that. Now it's Wednesday. I'm very happy for you to do it like now during your lesson. Don't rush to finish it. There's quite a bit of it because it does get difficult from this point on. Yeah, the rabbits are not a problem, but after that it does get a little bit more tricky. But it doesn't matter. Send me your work as fast as you can.